Okay, Assalamualaikum warahmatullahi wabarakatuh and good day again. So this is Shear Strength part 3. Okay, previously we already discussed introduction of the shear strength in part 1, and also we already see one of the shear strength tests to define CMV parameter, which is direct shear test. So in this video, inshallah, we will continue with the unconfined compressive strength test and also triaxial shear test, which both of these tests is actually using a similar soil chamber. Okay, soil chamber. Alright, so let's see the UCS test. Okay, the UCS test can be conducted actually for uh, two types of the rock and also soil. I believe we also have a compressive strength in the concrete test. Okay. So what the difference of the UCS test with the other triaxial test is, this UCS test doesn't use any confined pressure, or for the if we speaking from the point of view of the test itself, we doesn't include any water pressure. We doesn't include any water pressure in the soil chamber or the rock chamber. Okay, so this is some of the failure modes if we have a soil sample that been tested in the triaxial. So UCS also using triaxial actually, but doesn't have any confined pressure, doesn't have water pressure. So the soil sample failure can be either having only shear like this one. So we have a failure lines in the sample, or the sample doesn't have any failure line like the A sample, but we have a soil sample that become bulging or barrel. And we also can have failure modes that combine both of them, which is combine the barrel and shear all together. Okay, this is a picture of the UCS test for rock. So you can see a soil sample for rock or very hard soil can also be used this kind. Note that I believe this is some of the measurement tools. We can put a measurement to measure the displacement, such as strain gauge. So we can know what the difference occur during the application of the load from top. Okay. This is another picture. We can also see here loading with the soil frame, loading frame with the rock sample. So this is their tools. Okay. Alright, and this one is the one that we use for the soil sample. So the machine that I show here is quite old one. The recent one we already have a digital reading for the loading and also for the displacement. But this one shall be shared first, shall be explained first, as the original or the older testing frame is the basic one before we can go to the digital one. Okay. Alright. So first and foremost, of course, the soil sample. So we put the soil sample inside the pressure chamber. So we have a pressure chamber. So this one. Outside from the pressure chamber, we have actually the loading frame. So all the system is combination of the loading frame. Sometimes from time to time we need to calibrate the frame so that we know the loading that we applied here through the probing ring and direct to the soil sample is correct. We need from time to time to calibrate the frame so that the loading is correct. Okay, we have between the loading frame and the loading to the soil, we have the probing ring. Probing ring. So this one is to measure how much the loading that we applied to the soil. And over here and here is the dial gauge to measure the displacement, vertical or lateral displacement. So lateral displacement for to the soil in UCS it is a 0. So we note that minor principal stress or lateral pressure is 0 in the UCS. So if we have a we have a place to make the chamber pressure increase here, usually using water. But in the UCS test, we doesn't need to insert any water inside the soil chamber. We just let the pressure chamber have a void. Um, doesn't need to be filled by water pressure or chamber pressure. Note that actually in the soil sample we have a place to allow the water out, drainage of from the sample. But in the UCS case, it's not a big deal because we doesn't do in the undrained, or we usually do in the drain. We usually conduct the test in the undrained condition, not a drain condition. We doesn't allow any water to dissipate out from the soil sample. We doesn't have a consolidation process. Okay. So unconfined compression test. Okay. Just like I brief just now. So we have a probing ring to measure deviator load. Deviator load is additional or increment of the load during the test. Dial gauge to measure the vertical displacement, because when we apply the load, the soil will have a settlement, right? The soil will have a settlement. And this is the specimen of the sample inside the chamber or the cell. And this is the procedure. So at least we need to prepare a soil sample. Soil sample usually taken from the field. We sometimes need to trim the soil and make it into smaller cylinder with the height to diameter is 2 to 1. And as the cell pressure is 0, so stress free is 0. And note that during the loading process, the cross section of the sample is changed. So that's why we need to get the strain value so that we can calculate the area of change, the changes area. And we know that normal stress is P, or the loading over the area, original area. But because of the area is changed, so later we can calculate the stress using improved equation, P divided by A sub C, the changes of the area, loading divided by the changes of the area. And from there, because we know stress free is 0, so stress 1 is originally final stress plus the stress free. So now stress 1 is equal to final stress. So total of loading that apply is equal to stress 1. And from there we can plot a stress strain graph, and another graph is the shear stress versus the normal stress graph. Alright, let's go here. Alright, so note that we have a dial gauge to measure the displacement. We also have the probing ring to record the loading that we applied. So from there, as we know the initial height of the sample, so we can calculate the strain. We also can calculate the area, because area of the cylinder is pi d to the power of 2 divided by 4. The diameter of the d is diameter of the cylinder. And we know the load from the probing ring, so later we can calculate the stress. Okay, so this is stress that we want to know, deviator stress, okay, delta stress. So deviator stress at the maximum is our final stress. Okay, Sometimes, okay, the testing stop after a few reading that become more smaller to the compared to the maximum. So we need to take the ultimate load Q sub U or the final stress at the maximum value, not the one that we stop. Okay, we need to take the final stress at the maximum value, not at the one that we stop the test. So final stress also known as a ultimate load Q sub U. Okay, and Q sub U is equal to stress 1. So we know that stress 3 is 0. Stress 1 is Q sub U. So when we plot the Morse circle, we can get the CU value. We can get the CU value. So in the UCS, it is usually conducted for clay type of soil. So that's why we get the CU value. CU value. So tau at failure is also can be calculated if we know the Q sub U. We know the Q sub U, so we divide by 2 because it is half of the circle, so we can get the C sub U. Shear strength in terms of cohesion in the condition of undrained, because it doesn't allow any water to dissipate from the soil sample during the test of the UCS. Okay. Alright. So this is example of UCS test. Okay. We know that just now we already learned that dial gauge and probing ring will give the displacement and load value. But in this example, the load, the final load that applied to the sample is already given here. Means it's already converted from the probing ring. So we got 342 Newton. So we are also given the dimension of the soil cylinder, soil sample. And we know that the exchange of the L, the length of the sample is 5.1 millimeter. So we can calculate the strain later. We can also calculate the area change, and by knowing the load, we can calculate the stress at final. Okay. So let's see. Let's see the stress, the solution. Strain is equal 0.134, and stress at failure is 269. So by knowing the Q sub U or final stress, so we can get the cohesion. Okay, so cohesion is equal to this. So divided by 2 is 134.5 kilonewton per meter square. Alright. I think that's all for part 3.1 video. Later we will see for the triaxial test. So until we meet again, so Assalamualaikum warahmatullahi wabarakatuh and goodbye.